Welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on A+ certification program, but with few enhancements to improve your IT technical skills and knowledge. So if you haven't seen my previous videos, I'll post a link in the description for the playlist. This would be our 16th lecture in which I will cover operating systems fundamentals. The primary objective of this lecture is to cover high-level overview of computer system architecture, basic overview of what is an operating system, also known as OS, major types of operating systems, and client, customer, end user devices and servers. So general overview of all of these items. Computer system structure. Computer system can be divided into 4 components: hardware, operating system, application programs, and users. Hardware includes things like CPU, RAM, input-output devices, mainframe components, etc., etc. Operating systems includes controls and coordination of hardware applications and users, while application programs are specialized resources that are used to solve a computing problem or problems of users. For example, you use word processing to solve the problem of how to get a typed document into a computer, and you may use something like Adobe Photoshop or something like some other photo editing application program to edit a photo. If you want to edit a video like this one, you will use a software such as a DaVinci Resolve or something like that, or you will use a program like a VLC player to play a video clip that you would like to watch, right? So the application programs basically specialize resources that used to solve a computing problems of users. Users are considered as human resources, but also machines and other computers. So human resources are just like you and me, that is, who are interacting with the computers and servers. Those are actually human resources. Machines are basically mechanical devices that will allow them to interact with computer components. So those could be mechanical devices that would sense whether the door is closed or open, and that will interact with the computers or servers to let the system know, security system know the door is open or closed, for example. So those are used in heavy machinery and other applications. So that would be an example of how machines or mechanical devices interacted with the computer. The computer systems also interact with other computer systems for especially applications related to artificial intelligence, machine learning, and also cloud computing. We use multiple different computer systems interacting and communicating with each other. Those are all falls under the category of users. So we have 4 categories: hardware, computer systems, application programs, and users. And what we're going to go over today is the fundamentals or basics of operating system, which controls and coordinate hardware and applications and users. So what is an operating system, also known as an OS? An operating system is a system software that manages computer hardware, software resources, and provide common services for computer programs. Those must be loaded into the computer by a boot program. So the boot program is the one that initially boot up a computer before the operating system kick in. So the boot program is responsible for loading the operating system onto the computer or the server that you are going to turn on. And the application programs makes the use of the operating system by making requests for services through a defined application program interface known as API. So the API calls is what is actually used by the application programs to request information and do certain services and perform certain services through the operating system which the application programs are installed on. Operating systems can provide terminals, So those would be operating system without a graphical user interface, where you interact with the operating systems by using a basically like a terminal or terminal emulator. It's like a command prompt, which most users are familiar with on Windows. It doesn't have any graphical user interface. You interact with by providing it with certain commands, and that commands can create directories, run programs, create files, interact with other devices, set up networking, etc., etc. The graphical user interface, also known as GUI, is what most users are familiar with, especially in home use environments as well as some corporate and business environments as well. So the reason for being that if you are using Windows 10 or Windows 10 Pro, for example, in business environment, you are actually using the Microsoft proprietary graphical user interface to interact with your operating system. Even Microsoft Windows servers have two versions, one that comes with the graphical user interface version, and the other one that is called the core version, that will only have the terminal associated with that operating system. So the graphical user interfaces are used in Windows, used in Linux, used in many other softwares, including like handheld devices such as cell phones. And that will allow the easier user interaction between the operating system and the user itself. So instead of using a terminal, the user will be interacting with graphical items on a screen. Other features that would enhance the user experience and provide services and utilities are also part of the operating systems in many cases. These includes things like certain accessibility features, certain other features that will allow the user to easily configure the operating system, whether you want to change a simple desktop to whether you want to change the entire IP address and the TCP/IP stack, all the way from basic changes to user experience to some advanced level. So that will also be part of your operating system services. Operating system or OS fundamental architecture. So the operating system fundamental architecture I have covered in lesson 12. So you can recall that the operating system protection rings from the lesson 12. So I'm not going to detail on how this OS ring architecture works in this lecture, because I have already covered there. You can go ahead and check that out, and I will leave a link in the description as well as a card on the top right hand corner. Basically, what you need to understand is you have different separations associated with these different rings that will be separating the device drivers and applications and the kernel. And the operating systems operates in the kernel level, which is the most privileged option that you can get in the OS rings of protection. So that's all the fundamentals that you need to remember. But if you want to go into detail on how that works with virtualization and etc., you can check out my lesson 12 in this series. We have monolithic, layered, and microkernel operating system architectures. Again, for your A+ certification program, you do not need to know in depth of how monolithic, layered, and microkernel operating system architectures works. But what you need to know is these are different architectures exist, and they are fundamentally different in ways how the architecture is built. So for example, here is a monolithic architecture where you have an application and you have system calls interface, and that will be interacting with the items below. And here is an example of a layered architecture where you have a user applications and you have an input output management inside the kernel space right in the ring 0, and then we'll have the message interpreter, memory management, and processor scheduling underneath it. And here is an example, how the architecture works. For microkernels, you have an application, then you have a system, call interfaces, and the kernel comes way at the bottom. Again, you don't need to know these things in detail for your A+ certification program. You just need to know these exist. And examples of a monolithic operating system would be the DOS operating system. A layered is the most commonly used operating system architecture. An example of that would be the Windows NT, Windows NT architecture is what is being used in Windows 10, Windows 11, Windows Server 2022. They are all based on Windows NT architecture, and it is a type of layered OS architecture. And BlackBerry QNS operating system is a microkernel operating system architecture that is being used by car manufacturers, especially with the QNS based operating systems on their navigation system and entertainment system modules. Those car manufacturers that are using QNS for their navigation and entertainment systems within their automobile systems, they are using the microkernel operating system architecture. Again, you don't need to know much detail about different architectures, but you need to know these architectures exist and they are different fundamentally how they manage the operating system. So types of operating systems include the Windows, Mac OS, Linux, and mobile operating systems. Windows operating systems include desktop and server editions. Mac OS only desktop right now you can get for that flavor. They don't have a server flavor, but the reason for being the Apple Inc. has discontinued Mac OS server edition a few years ago. So therefore we only have the desktop version of Mac operating system, while the Windows have both the desktop and server editions. Linux is open source operating systems as well as some closed source operating systems. So many distributions, also known as distros, support specialized use case scenarios. You can get desktop operating systems, server operating system, and other purpose-built distros as well. So the purpose-built one could be Kali Linux for learning how to hack, like ethical hacking, for example, that are used by Kali Linux operating system. Desktop operating systems could be something like Ubuntu Linux, and the server could be Red Hat servers. And again, Linux operating system can be paid or free, but most of the Linux operating system architecture is open source, and most users have the ability to get them for free. Mobile operating systems include Android operating system, which is based on Linux operating system, iOS, which is based on the Mac OS from Apple, Chrome operating system, which is based on the Chromium project that can be used, that is used on certain mobile devices, such as it's like a laptop, but it's based on Chromium operating system. Windows Mobile is a legacy operating system that is no longer in production but used to be part of the Windows Mobile operating system mobile applications. So you may come across Windows Mobile. Again, I have covered that a little bit in detail in my previous lecture as well. Customer requirements. So when you're selecting an operating system, you have to think from your customer's point of view as an A+ certified technician. You need to consider the following for the home users. Things like, are they familiar with Windows or Mac operating systems? So if they are more familiar with Windows operating systems as opposed to Mac operating systems, do you really want to push your end user to use Mac? See, you need to think about that. Even if the Mac may be the best option for your end user, you can educate your end user about the Mac operating system, but you don't need to push it for your end user, because that will create more headaches for you. If your end user is more familiar with Mac operating system but not so much familiar with the Windows operating system, the same same concept will go for that as well. You don't want to push your end user to use Windows operating systems if they are very comfortable with using Mac operating systems. The only time that you may push Windows or Mac operating system to your end user, there may be certain use case scenarios that the certain functions of either Windows or Mac OS is so good for your end users applications, or use case scenario where you have to little bit push that in one direction or other, because you want to make sure that your end user get the best experience possible. So that's the only reason why you would push your end user towards one operating system or the other, or otherwise just go with whatever the one that they are familiar with. Another one you can ask yourself is, are they familiar with Linux? Maybe they don't want to go with Windows or Mac OS. Instead, they want to go with open source Linux operating systems. In that case, you could recommend well-known Linux distros such as the Ubuntu desktop version, for example. Do they need file servers? For example, in home environment, they may want to host movies, family pictures, etc., on a centralized server. So you can create an FTP based server, or you can buy one of those small NAS, network attached storage devices for your end user. So those are certain things you need to consider. But one thing you need to educate about your end user is NAS devices, for example, have their own flavors of typically Linux or Unix like operating systems, and you just need to educate your user about graphical user interface and the operating systems associated with those type of servers if you are to install those servers at a home environment. You could also ask your end user what applications they will maybe using on the operating system, and based on those applications, again, you can recommend whether they should use a Linux, Windows, or Mac OS. But at the end of the day, I would highly not recommend that pushing home users to use one operating system or the other unless it's really warranted. Consider the following for the business and enterprise environments. So you need to ask, do the customer need a dedicated in-house server? Because if they don't, maybe you can use services that can host whatever the applications and the meet the requirements and demands of your end user with a client, cloud-based environments. So those could be AWS, Google Cloud, Microsoft Azure, Cloudflare, etc. For example, if your enterprise or business client need to have a dedicated DNS system, instead of building a DNS server, maybe they can go with Cloudflare, right? Or they can even use DNS services from Google Cloud as well. You can buy the Google Cloud dedicated DNS lines services. So think about that, because that may be cost effective in the long run. So especially for small businesses, so depending on that environment, you need to make that decision and recommend that decision to your enterprise or business clients. Use in-house servers for in that case scenario where you have to use in-house servers. Think about virtualization with a type 1 hypervisor, because that is a really good option. I don't see any scenario in 2022 especially for small businesses that you just have to use a dedicated server for one single operation. So even if you are using for one single operation, I would still install something like VMware EXXi Type 1 hypervisor on that physical server. So in the future, you have the capability of putting other additional operating systems and servers and system operating components as virtual machines. Like for example, if your business or enterprise client say, I need a Windows Server 2022 install on this business environment, and that's all I need for now, but I may need some other operating systems and other software that may need to be installed outside of Microsoft Windows Server 2022. So if that's the case, what you can do, you can take the server, and if you're installing it for the first time, install a Type 1 hypervisor such as VMware EXXi. And then what you can do, you can install the Windows Server 2022 on a virtual machine. And when later date, maybe a month later, your client come back and say, I need a Ubuntu server too. I need a Red Hat Linux server too. If that's the case, no problem. You can spin up another virtual machine with these different operating system requirements, and you can easily scale it up or even scale it down or like remove the operating systems or virtual machines based on your client's need. So instead of installing the Microsoft Windows Server 2022 directly on the in-house servers, you are installing a Type 1 hypervisor, and on top of that Type 1 hypervisor, you are installing the Windows Server 2022, and then later you can install other virtual machines. So that's something that you should recommend to your especially small business owners because they don't know about these features. As an IT technician, as an A+ certified IT technician, it's your job to educate your end user, even your business and enterprise users. So keep that in mind. So enterprise environments, typically they do have their own IT teams that probably go over all of these options. But even then, you need to mention those things during your business meetings. Also, you need to ask the questions, are there any specialized software used by the organizations? And you need to change your recommendations and based on those kind of specialized software that may or may not be able to run on certain operating systems. So for end clients, for example, so if you have 200 employees in your let's say business or enterprise environment, and these employees have certain programs that can only run on Windows, for example, or certain programs that are optimized in Mac OS. Like let's say you are installing end client devices for a movie production company that has Mac operating system based movie editing software. You don't want to install Windows because that's going to create a headache for you. So make sure that you customize to your clients based on those kind of requirements. So for example, I work for an organization that uses specialized software that only run on Windows. So I can't go ahead and install Mac OS because I need to make sure that my end users have Windows. So you need to ask that questions at the very beginning of your projects so that you are not getting blindsided when you are installing those end user software as well. So you need to ask that question. And this also apply to servers as well. So certain server specialized softwares may not be able to handle on Linux servers. So in that case, you need to make sure you have a Windows server installed, for example, right? Keep that in mind. Thin client installation. So you may have heard the term thin client versus thick client, and I will quickly go over both of them. A thin client runs its application from a server. Image management software is used to install an operating system and drivers, and significantly lower processing power is needed to run these thin clients. Hence, it is very cost effective. Configuration information commonly needed to deploy a thin client include the MAC address and or IP address, monitor settings, domain or username information, and drivers. And they typically don't have a operating system running on the client itself. And examples of thin client usage would be a POS, like a point of sales. So if you go to the store like Superstore, Canadian Tire or something like that, and you buy an item from a Canadian Tire, the Canadian Tire cashier is probably going to use a thin client to access the operating systems associated with, or the software or firmware associated with their billing system, and that's how you get a printed receipt. So basically, the machine that is at the cashier or cash register is not the entire operating system, not the entire database. The database is in a server. So it reduced the cost associated with deploying this kind of machines. It also increased safety and security as well, especially when it's come to data protection. So if a thief or a threat actor walk into the Canadian Tire or Superstore or something like that, or to let's say, to a library, for example, here's an example of somebody installing a thin client on a library. The amount of data they can take by just stealing this device is next to nothing. Unless the user actually saves something on the desktop, for example, most of the information gets saved onto a server, and hence the security goes up as a result of using a thin client as well. They are also highly energy efficient. So for example, if you put these items on a library, internet access centers, like internet access points, basically the user will get access to library resources and the internet, and that's it, right? So you don't need that much processing power, you don't need much RAM, you don't need much to do with this machine. So the use of power is also gonna decrease, like in terms of energy efficiency. So keep that in mind as well. Thick client, also known as fat clients, are basically your desktop computers or your laptop computers. Those are all considered as thick client or fat client computer installations. So those are thick client has applications that are installed locally. So that could be Adobe Photoshop, it could be Microsoft Word, Excel. So if you don't use the Office 365 online version with the thin client, which can be done, you can do thick client installation of the full Office suite onto the client itself. You can do much more advanced things such as video editing, as I mentioned, and some unique apps might have to be installed manually on those thick clients that otherwise may not be able to run on the thin clients. So the configuration option for thick clients includes the network printer or local printer installations, applications, account settings, computer settings, including desktop icons, wireless options, and so many different things. And almost all desktop computers and laptops are considered thick clients devices. I just want to remove a confusion here. On the A+ certification program, outline, they mentioned the configuration option, network printer and stuff like that on the thick client, but did not mention that on the thin client. But actually you can install printer and other network printer configurations in the thin client as well, but you may not be able to install the printer software. So for example, you may have a network printer that is associated with a thin client where the user can print to that network printer, but it cannot scan, for example, or change the printing certain configuration. They can just print. Like for example, a lot of libraries use this to just print text documents. But in the flat client or thick client, you can install the entire suite of that printer's software, so you can have much more advanced features. So that's what makes the thick and thin client different slightly. I don't know why the A+ certification document that I looked at only mentioned the printer installation on the thick client, because maybe that's why it's most commonly used. But again, I just want to highlight, you can install printers on thin client too, but it's going to be most likely going to be a network printer as opposed to thick client. You can do local printers as well as you can install specific printer software to manipulate certain things like the print quality, etc., etc. There are variation in clients that are done by different manufacturers. Here's an example of that. So the HP take on thin client variation is called Zero clients. That they based on something called their secure PCOIP architecture. So this is a PC over IP protocol. So this is how, this is a one way. This is one of the ways that a manufacturer specifically taking on a different version, a different variety of clients. So they are basically secure stateless endpoints that deliver rich user experience when connected to a HP proprietary CAS or a VMware Horizon or Amazon Workspaces desktop and workstation. So there are like different way of communicating is facilitated. Different way of communication is facilitated to the end user using these type of different clients. So the thick client is the typical desktop laptop that you see on everyday use. Then the thin client that I mentioned in my previous slide. But the Zero client is another variation of thin client. At least that's how I look at it. And it has a higher lifespan, as you can see, because it doesn't require much usage of power, for example. Even thin client have a higher lifespan than a thick client. And it basically, these type of client, thin client and the Zero clients are used to access cloud resources. So if you want to read more about these type of resources, cloud or virtual resources, you can go to this HP site as well. I will leave a link in the my description as well. For A+ certification program, you just need to know that the variations exist from vendor to vendor, and there may be different takes on the thin client devices depending on the manufacturer. So that's all you need to understand for your A+ certification program. You just need to know those exist, but you don't need to know any more depth than that. The another thing you need to think about is a local server installation, which I briefly mentioned on my previous slide. Remember, the local server installation has to allow the installation of applications and services that can be served to multiple clients. So those includes the mails, web or file servers, applications hosting, routing, firewall, VPN, all of those things you need to ask from your end user, your enterprise or business user, and ask them what they need, and you need to install them accordingly. Higher computational and logical capabilities are typically associated with local servers as opposed to local desktop or thin clients. Allows centralized control and management on software and applications and services, because all those services will be installed on that local server. As a server administrator or system administrator, you would be able to centrally control certain features. So those includes things like Microsoft Active Directory domain controllers and users. For example, the authentications, you can do things like that. So for example, in business and enterprise environment, you can implement AAA. AAA is the authentication, authorization, and accounting. I will go into depth of that in a separate lectures series that I will be covering. And for now, you know that those can be done through local servers. You will have a high initial cost, but in the long run, it could be cost saving as opposed to installing some of these programs and features on every single client device, right? And every single client device, especially if you have like 200 employees, it may be better to serve some of those features and programs through a local server. Linux and Microsoft server type operating systems are very popular. Those are the two server types, Linux and Microsoft. As a technician, you should be familiar with both Linux and Microsoft and get to know at least basic troubleshooting processes associated with Linux and Microsoft. Mainframe operating systems. So what is a mainframe operating system? Well, you may have heard the term mainframe at work or out about, and basically mainframe systems are computers that are able to process billions of calculations and transactions in real time, securely and reliably. Yes, even as of 2022, we still use mainframe systems widely in many industries, from banking industries to government to even some corporate and enterprise environments, because that allow us to process billions of calculations and transactions in real time and can support multiple different infrastructure at the same time, securely and reliably. IBM is the major player in the mainframe computer systems, and it is probably the basically dominant player in the industry. But I would say close to 90% of mainframe servers in Canada, for example, is run by IBM. But please don't get confused between mainframe computers and a supercomputer. So the mainframe computers are associated with, or concerned with, processes of billions of calculations and transactions, and they are highly reliable, highly secure, and their main focus of is the reliability, security, and the billions of calculations of those transactions day in and day out. So the mainframe servers are typically run 24/7 and doing all those heavy lifting, whether it's international financial transactions to all the way down to international credit card transactions, or all the way down to something as simple as running a small oil rig on a oil companies, like a small oil company. All that data has to be run reliably and securely. That is the main focus of a mainframe computer. A supercomputer is different from a mainframe computer, because supercomputer is interested in like how many calculations can be done per second kind of thing, how fast and a computation can be done. Mainframe is not interested in how fast the computer can be done. It's interested in how processing billions of calculations and transactions in real time, securely and reliably. While the supercomputers are interested in how fast those calculations can be done. Supercomputers are far more expensive and typically used by research organizations, institutions such as universities and NASA, etc., while the mainframe computers are used by governments all over the world. Large companies such as British Petroleum, Encana, Cenovus Energy, like oil companies in Canada, for example, they use it. Mainframe computers are also used by for example, airline companies. Everywhere you go in industry, you will come across mainframe computers, but you hardly will come across supercomputers. And if you get to work with a supercomputer as an IT technician, that would be pretty cool. But if you get to work with mainframe computers, it's a normal everyday item that you may come across. So the mainframe computers have to use typically specialized operating systems. The most common operating system currently in use in Canada and North America is the IBM Z operating system, or IBM Z operating system. That is the most popular as of 2022. And as you can see, because there is no need for a graphical user interface, because they will be used mostly by system administrators and IT technicians like you, it will be a terminal like this. So this is an IBM Z operating system that is used typically in 2022, and this is what it look like. So it will have all of these items, and you will be using mostly keyboard to interact with the IBM Z or IBM Z operating system, because it won't have any graphical user interface, and they probably don't support mouse input either. So it has basic input, output. However, it is very powerful and reliable. So that's why we still use mainframe systems, and they are very popular in governments, large industries and enterprise environments, but you may come across in small businesses as well. And that is the end of our lecture. Please don't forget to thumbs up this video and subscribe to my channel. Until the next lecture, good luck with your exams and have a nice day.